Hello, my friends of Katari Labs. My name is Saul Montoya. Today we are going to do a tutorial where we are going to simulate a brine, okay? And in this case, the brine is sodi sodium bicarbonate, okay? And then we are going to simulate this. We are going to react this. We are going to react pure water to different concentrations of sodium bicarbonate in order to get the curve in between um, concentrations and density, okay? Because we want to see which for each concentration which is the corresponding density for this brine, okay? This could be applied to every brine, like for example acid, boric acid, sodium bicarbonate, sodium chloride, potassium sulfate, lithium sulfate, and sodium sulfate as well. Okay, because these are the, well, or based on the geochemical speciation of a salt lake in China, these are the most common brines that are going to appear there. I mean, there are more brines that are going to appear on the that that are going to exist on a salt lake, okay, but these are the most common ones, okay. Well, where we got this for another simulation in Phreeqc, where we evaporate almost all water from the where we evaporate almost all water from the salt lake, and we got several species, okay, but these are the most abundant species. Okay, so this is the file, okay, and this is with the in extension that is required for our platform Aquifer App, and then we are going to simulate this, and then we are going to export the densities, and then we are also to export um, well, the densities and the volume, okay, we are going to export that, and then we are going to create, okay, we are going to transform from moles to grams per liter, okay, the concentrations, and then we are going to compare that to the density, and even we are going to do a regression line over the density and over the concentration and the densities. Okay, so let's start. Okay, so we start. Okay, I will delete my history just to create a great. Here we are in Aquifer App. Mhm. Okay, you sign up with your account. Okay, you create a new project like Brine. Okay, then you open Phreeqc. You select the ink file. Okay, that is modeling brine density versus concentration curves. Okay, this is the place of this file here. Upload. Okay, and then we go to setup. Lithium is under the normal Phreeqc database. Okay, so actually you don't have to use another database. Okay, and run. Okay, it has run well, and then we compile the results, and then we can see the results. Okay, so this is for the molality for the first reaction. Uh, this is the initial solution. On the first reaction, actually there is no, because the first the first concentration is actually 0, so it has to be the same. Okay, and then later on you have, okay, on the reaction number step 2, for the reaction step 2, you have 1 mole of sodium bicarbonate, and then for the next reactions you are going to have, no, you have 0.5 times 1 mole. This is for the second reaction. Yep. Yeah, 0.5. Okay. And then for the third reaction, you will have 1, 2, and the last amount is 12 moles. Okay. Mhm. So, for example, let's see to the solution description. So the first reaction, the density is 9.97, okay, great, and the volume is 1, while for the last reaction, the density is 1.56, 53, 54 almost, and the volume is 1.3, okay, so and from the species, from the solution composition, sorry, for the solution composition, for example, at the last, here we have 12 moles of calcium and 12 moles of sodium, of carbon, and then of sodium. Uh, so, well, we are going to get the, well, actually it's 12 moles, but the molality is 11.96, okay? So we can get from the molality as well the concentration, but we are going, since we know how much sodium or how much sodium bicarbonate enter the solution, okay, we are going to get those concentrations or get the mass of this, okay, divided by the volume of the solution description, okay, divided by the volume, okay, and then we have the concentration, and then we are going to compare that for every reaction, okay, and then we are going to do that, but not on Aquifer App, but on a next step that is on Python. So for that, based on the tools of Aquifer App, we are only going to export the solution descriptions, okay. Let me clean this for you. Solution description. Okay, so we download the solution description. Okay, we are going to copy that, Control C, Control V, okay, and then here in this folder that you are going to receive in the description of the video, we are going to run a IPython notebook, okay. So let's see, Anaconda prompt, cd documents, cd modeling, okay, and then here we just type Jupyter Lab, okay. So okay, kernel clear all outputs, okay. First, we import the required libraries, okay. Then we read the solution description file, that is the one that we download from the Aquifer app, okay. And then we have, okay, many rows, but we are interested in one that is the one for density and the other that is the one for volume, okay. So we get just the density rows, okay, and then just the volume rows, right? And just not for the initial solution, but for the reaction. Okay, and these are the mole amounts that are the same as this one, okay, as this one, and this is the amount of sodium bicarbonate in each simulation or in each reaction, okay, and then we have here the molar, okay, let me, sorry, this has to be updated. I need the molar max, the molar mass of sodium bicarbonate, sorry. So the molar mass of sodium bicarbonate is 84.01. Okay, then we filter the simulation for the given, well, for the index, okay, but there is only one index, so don't worry. And then we set the batch reaction number as an index, okay, and then we order, okay, since this is a call from the database, from the database, okay, the order is actually not implicit, so we have to give an order, okay, based on the number, okay, and then we can print, okay, so for every reaction, okay, you have the density, and for every reaction you have the volume, okay. Then we create another data frame, okay, where you have the mass, but the mass you get it from the mole amount times the molar mass, and the volume you get it from the data frame, okay, and the concentration is the mass divided by the volume, okay, in grams per liter, and then you create another column with the density, okay, so you have one column for the concentration and another for the density. This is what you have, one for the concentration and another for the density, okay, and then we just run a simple uh, code that creates the graph and also give you a regression line in between the concentrations and the density, okay. So we just run this, okay, and here you have for each concentration you have this density, and this is a linear, it was expected that it was linear, okay, and this is the regression equation, okay, where you have this concentration, and for this concentration, if you multiply by this value and add this constant, you will have the density values, and this is for sodium bicarbonate, okay. You can, I mean, this example was expected for brines in salt lakes, okay, on lithium-rich salt lakes, okay, and you can run this for any. I mean, you can modify this for any other brine, okay, and you just have to change the brine here and change as well the molar mass here, and this will, and the name as well, and then you will model the relation with other brines, okay. It's amazing. Well, so this is the result. Why do we do that? Because intensity driven flow, okay, the values will be adjusted by the values will be adjusted by the okay, the flow is adjusted, I mean the groundwater flow by the density. So actually it will matter which the density of a brine in order to see the impact of that density on the flow. Okay, so it's I'm talking about mod flow with the by package. Okay, that is the next step of what is going this tutorial. Okay, so thank you for your attention. Thank you for uh, waiting for this explanation that is kind of very dense, okay, and I hope that my approach will have given you a better approach on this topic. Okay, just to remind that we are Hatari Labs, okay, that we have lot of courses, webinars and diplomas that you can take. Some of them are live and some of them are recorded, okay, and then you can take it and then you can start at your own rate. And just to remind that by taking our courses you support our research. Okay, have a great day and hope to see you in another tutorial. All the files will be on the description of this video.